little bit blur.
For me, it's very clear.
Good morning, sir.
Good morning.
It's very shady, sir.
Good morning, sir.
Maybe shady for you.
No, sir.
Maybe shady for you. From my side, problem is not there. It's very clear for me. What I am observing on the screen, it's very clear.
Good morning, sir.
Good morning. So whomsoever is feeling that it is getting blurred, ask your family members to withdraw from the online. If they are busy on the WhatsApp and the Facebook, ask them to withdraw. Now I'll go for the doubt clarification. So already yesterday, a lot of doubt clarification I have done. And just I am observing that more than required number of the boys and girls have joined my class. What I'm feeling that in today, more than required number of boys and girls have joined the class. What I'm feeling, because according to me, the class strength is only 79, but now at present 123 members are there. So I'm feeling that some members have joined by mistake. And whatsoever the doubts I have done yesterday, I won't repeat today. Whatever the doubts I have done yesterday, I won't repeat today. Very careful. Very careful. Because I have given information to you day before yesterday. Yesterday morning, I have given this class. I have given information to you that in the evening we are meeting. Principal has given information to you. In spite of so many informations, strength was only 79 and total strength is 200 plus for you people. 200 plus for you people, and that was the condition. And that is the reason why I have not put any comment. Simply, I have mentioned that this shows your sincerity and commitment towards your goal. That's all. This shows your sincerity and commitment towards your goal. It is there. Whatever your goal it is there, it's very clear. It's very clear that most of you are again joining to us in the long term. Yes, most of us, you are again joining to us in the long term, and you people are making us rich. If not joining to us, you will join your you'll pay some money to the other college. Other means other college. Yes, because those whose vision is not there, for those whose aim is not there, always they are going on searching for reasons, always some reason. Why you are late, having the reason. Okay. Why class you have not attended, some reason you are having. So those boys and girls who are always finding some or the other reasons, for them becoming doctor is not good thing. And definitely if they will become doctor, I'll feel bad. Yes, I'll feel bad. Because definitely they won't be good doctors. They'll be Jack the Rippers. They will be Jack the Rippers, or they will be the money launderers. And definitely for a good society, I don't want money launderers and the what? Jack the Rippers. Now coming for the topic, objective 1. Objective 1 I have not done yesterday. Yesterday straight away I have gone for the what? Objective 2. Today you can clarify the doubts straight away. I am asking from the objective 1, 2, 3, 4 and the order form I'll go for. Wherever doubt you are having, definitely ask. So first I'll go for the test portion. Objective 1, electrolysis. So I'm going for electrolysis. Question number 18 to question number 20. Question number 18, objective 1 yesterday I have not done. So whether whomsoever there or not there, openly you can ask. 18th to 20th. 21 to 25.
Sir, in the 22nd one, I just had a doubt whether lithium hydride will be found or not.
No. It is just like sodium chloride. It is just like sodium chloride. So for the sodium chloride, you are getting sodium hydroxide. For the potassium chloride, you are getting potassium hydroxide. So for the lithium chloride, you will get lithium hydroxide. And lithium hydroxide is basic in nature, and therefore pH of the resulting solution is what increases. Why? If you will go for the Li plus LiCl, it will be Li plus aqueous, it will be Cl minus aqueous. This will go towards anode. At anode, preferential discharge of the Cl minus occurs. So therefore, this will be the reaction at the anode. This both will go towards cathode. At cathode, this discharge potential is less, and therefore reaction will be this one. Already at the cathode, Li plus it is there. This leftover Li plus and the formed OH minus, it gives rise to lithium hydroxide. Lithium hydroxide is basic in nature, and that is the reason why pH is what? Increasing. Clear, beta?
Yes, sir.
Okay. Any doubt up to question 25? Any doubt? When 60% of you are not there yesterday, at least now ask. 60% of you are not there yesterday, now you ask. मरे हुए मुर्दे जैसे मत बैठे रहो, like a dead souls. Okay, open your mouth and ask. मरे मुर्दे जैसे बैठे रहते हो. (21 to 25) in doubt?
No, sir.
No, sir.
26 to 30.
So 29.
29th is the example of active electrode. 29 is the example of the what? Active electrode, it is there. 29th is the example of active electrode. And the trick I have taught you for the active electrode, it is there that electrode and the ions will be of same type. Electrode and the ions will be of the what? Same type. Clearly in the question they have mentioned nickel electrode, it is there, and this is our anode. While teaching you theory part, I have taught you theoretically active electrode can be anything, maybe cathode, maybe anode, but practically it is what? Anode, it is there. And when the electrode is active, at the active electrode, normal expected reaction won't occur. So what is the normal expected reaction? This is the normal expected reaction. It is there. Normal expected reaction is not occurring. At active electrode itself undergoes a dissolution. Electrode undergoes a dissolving, and whatever our nickel electrode it is there, it itself will dissolve and undergoes anodic dissolution. Loss of electron means oxidation. At anode, oxidation only occurs. Anything up to question 30? 31 to 35.
33, sir.
36.
I'll go for 33. Anything before 33?
No, sir.
No,
Anything
sir.
before 30? No, coming for 33. Now tell me, in the question, what they have asked? What is the main question? What is the main question? Which of the following reactions occurs at anode? Which of the following reactions occurs at anode? At anode, what reaction occurs? Oxidation. That's all. At anode, oxidation occurs. So just you have to go on cross-checking. Don't go on solving all. Cr plus 3, it is transformed into Cr plus 6. That's all. First option. Cr plus 3, it is transformed into the what? First option. Can I say that this is oxidation? Yes, it is oxidation. Second one is F2, it is becoming F minus. 0 to minus 1, it is reduction. So therefore, this is not the answer. If I am going for the third one is oxygen to O minus 2. 0 to minus 2, it is nothing but reduction, it is there. If I am fourth is none of the above, it is there. So from this, it's very clear that first option is the only oxidation, and at anode, only oxidation occurs. Anything up to question 35? 36 to 40.
36.
36. During the electrolysis of the aqueous solution of the following, molarity of the solution increases without changing the chemical composition. It is sulfuric acid. It is a sulfuric acid, and this is the question in the class we have done. Sulfuric acid and the nitric acid are those where molarity is increasing. If I am going for NaCl, in NaCl, Na part does not undergoes electrolysis, but Cl minus is undergoing electrolysis, therefore composition changes. In HCl, H plus is nothing but water. Cl minus is undergoing electrolysis, composition changes. In copper sulfate, sulfate does not undergoes electrolysis, but copper ion undergoes electrolysis, and that is the reason why its concentration is or composition is changing. In sulfuric acid and the nitric acid, check the table. I have mentioned to you, strictly speaking, water only undergoes electrolysis. If water is only undergoing electrolysis, volume of the water is decreasing. When volume is decreasing, concentration is increasing or molarity is increasing. Therefore, answer is sulfuric acid. Anything up to question 40?
39. sir.
Question 40, sir.
39. Before 39? Before 39. 39 is a class question. 39 is a class question. Kastner-Skallner's process, mercury cathode process. This explanation I have given in the class. What explanation I have given? If we are having platinum electrode, it is there. In the platinum electrode, we are having Na plus and the water. You say water or the H plus, both are one and same. Discharge potential of the water is less. But if we are having mercury electrode, it is there. Na plus and the water, or we are having H plus, it is there. When mercury is the electrode, discharge potential of the Na plus is less, or discharge potential of H plus is highest. Check any option it is there. Can I say more voltage is required to reduce H plus at mercury than at platinum? Can I say?
Yes, sir.
Yes, it is the answer. Anything up to question 40? Anything up to question 40?
Sir, 40.
Clearly, question is saying hydroxyl. Which minus? Which minus? Because in the question they have not mentioned water. In the question, if they would have been mentioned water, in the question is saying discharge at cathode. Question is saying discharge at cathode. Discharge at the water, cathode, it is there. Discharge at the cathode, it is there. Cathode means which of the following ion is discharged at the cathode when aqueous solution of the sodium hydroxide? So if I am going for the at cathode water, as water they have not given, check anything nearby water. Anything nearby water. What is nearby water?
Hydrogen.
Hydroxyl ions, OH minus. 41 to 45.
Hydrogen. So for the 40th question, first option is given. So.
When the aqueous solution of sodium hydroxide, it can't be hydrogen. If it is hydrogen ion, answer is correct. Then better make it hydrogen ion. Then change the first option and go for the hydrogen ion. Because where is the hydrogen here? In sodium hydroxide, where is hydrogen? Hydrogen is not there. Hydrogen is not there. It should be hydrogen ion. Hydrogen ion. From 41 to 45.
43.
43, they have given the value of discharge potential. They have given the value of discharge potential. That is one trick. Even if they are not giving the value of discharge potential, 4 or 5 days back, I have taught you that alkali metals and the alkaline earth metals are practically does not undergoing discharge. Alkali metals and the alkaline earth metals are practically does not undergoing discharge. When practically they are not undergoing discharge, so can I say discharge means only copper will go, mercury will go, and silver will go? Can I say?
Yes,
Yes.
sir.
Can I say? Now in them, if I am going for them, in them, discharge potential of the water, mercury is least. Discharge potential, hey, whatever they have given, that is SRP, that is a reduction potential, it is there. Reduction potential and discharge potential may be same or may be reverse. In this case, higher is the value of SRP, reduction potential, lesser is the value of discharge potential. So I am telling you, discharge potential of the silver is least, then we are having mercury, then we are having the copper, it is there. Therefore, answer will be third option. And in the PDF file, you might have observed, I might have given by the arrow in terms of the SRP, in terms of the discharge potential also. SRP word is also used in terms of the SRP and in terms of discharge potential. Check SRP word is there. In the PDF file, what is the order given? Yes.
For discharge potential is given.
Anything up to 45? (46 to 50?
So 49.
Coming for
So
49.
Yes.
No, coming for 49. I'll go for the 49. 49 is those team who were absent yesterday. Yes, those who were asking question 49, they were absent yesterday. Yes, am I correct?
Sir, I was present in the class, sir.
Then present in the class, why you're asking this question? This question is a very simple question is there. This question is a very simple question. Question is, when a quantity of electricity is passed through copper sulfate using 0.16 grams of the copper, same quantity of electricity is passed. Same quantity of the current is passed through different coulometers connected in series, I will apply formula W1 by W2 is equal to E1 by E2. In this question, time is not given, current is not given. So first law you won't apply, you will apply second law. First law you won't apply, you'll apply second law because only weight is given. Equivalent weight you have to know. Maybe from stoichiometry or maybe from the solutions and the colligative property. In our question, we are bothered only regarding the copper. In our question, we are only bothered regarding the copper and hydrogen. Clearly in the question, they have mentioned for the copper, weight is 0.16. Weight of the hydrogen, we don't know, but equivalent weight of the hydrogen, we know as a 1. Equivalent weight of the copper is actually 31.175. Take it 32 for easy solving. Gram atomic mass of the copper is 63.5. So half of the 63.5 will get fractional value. But if you will take gram atomic mass of the copper is 64, then atomic mass will be 32. If 32, this solving will be very easy because 16 twos are 32. So therefore, we should always take easy thing for convenience. And now here I am talking equivalent weight is 32. Why? Equivalent to weight of the copper is equal to 64 by 2 is nothing but 32. By this, I have to go for the weight of the hydrogen. So once I am going for the weight of the hydrogen, so can I say it is this one?
Yes.
Yes, sir.
Once I got this one, now I'll apply the concept of the stoichiometry. Why stoichiometry, sir? Because if you check in the question, weight they have not asked. In the question, they have asked volume at the what? STP. So now I'll apply 2 grams at STP is nothing but 22.4 liters. Here, all the options are given in terms of CC. Therefore, I will take in terms of CC only. This is 2 grams is occupying 22,400 CC, and therefore 5 into 10 to the power of minus 3, how much equal to So x is equal to 5 into 10 to the power of minus 3. This it is there 2.24 into 10 to the power of 4. And then I'll go for this as a 2. Solve it and get the nearest answer.
56.
Anyone doubt in this beta?
No, sir. Thank you, sir.
Any doubt up to question 50? I am teacher, no? I am teacher. I can't keep grudge with you. That is the difference between the teacher and the tutor. Even those who are absent yesterday, they to ask anything, I'll help you. They to ask anything, I'll help you. Whatever questions I have done yesterday, you ask what to do now. From 51 to 55. From 51 to 55.
53.
Now coming for 53. For the charge of equal mass of the following ions, the number of electrons required is maximum in the case of H+. Maximum in the case of H+, wheresoever number of equivalents are less. Just I'll give you solving part I won't do. Solving part is complete. Solving I won't do. Just framework I'll give to you. Now they have given equal mass. Equal mass means take simple value only 1 gram. I'll go for the 1 gram. So you know very well equivalent weight of the hydrogen. You know very well what is the equivalent weight of the hydrogen. Equivalent weight of the hydrogen. Question is saying the number of electrons required. Number of the electrons required. So 1 gram is nothing but equivalent weight. Equivalent weight is Avogadro number of electrons. And you are assuming the weight as a 1 gram. This is the weight you assumed. So can I say number of electrons are Avogadro number only, can I say? Can I say? Now I'll go for the second one, copper. For copper, 32 grams is called as an equivalent weight. So when equivalent weight it is there, Avogadro number of electrons are there. Therefore, for 1 gram, from where this 1 gram coming? I have assumed equal mass as a 1 gram. So therefore, for 1 grams, can I say for 1 grams, this is X. So can I say it is, can I say?
Yes.
Yes.
Now, I'll go for the third example given Ag plus. Ag plus means 108 grams is equal to equivalent weight. So therefore 108 means 23 electrons. Therefore 1 grams is equal to how much? Now I'll go for the last one, aluminium. Aluminium means 9 grams is equivalent weight. So 9 grams is equal to Avogadro number of electrons. Therefore, 1 grams is equal to here Avogadro number by 32, Avogadro number by 108, Avogadro number by 9. Which value is the highest?
7.
Avogadro number is the highest.
So,
Hmm.
question number 55.
Question 55 I'll go for. This one clear?
Yes.
1 Faraday of electricity will liberate 1 gram atom of the metal from the following. Wherever charge is 1, that's all. Wherever charge is 1. Wherever charge is 1. Wherever charge is 1. 1 Faraday is equal to 1 gram equivalent weight. 1 gram equivalent weight is nothing but equivalent weight in grams. This will be equal to gram atom or gram atomic mass. So 1 Faraday will be equal to equivalent weight or the gram atomic mass if n factor is 1. If charge is 1, if a charge is 1, then only equivalent weight and the atomic weight will be same. So if n factor is 1, in that condition, equivalent weight and the gram atomic weight both are same. Let us go for the first option. First option is Cu plus 2. In Cu plus 2, charge is a 2. So 2 Faradays is required for 1 gram atom. 1 gram atom does not means 1 gram. 1 gram atoms means gram atomic mass. Gram atomic mass for 1 gram atom, also called as gram atomic mass. Next example, I'll go for the copper sulfate. Again, copper sulfate, same thing. Next example given is Ag plus. In the case of the Ag plus, 1 Faraday is required. 1 Faraday is required for 1 gram atom. Next is Al plus 3. Au plus 3 means 3 Faraday is required for 1 gram atom. And question number 55 is the same type of the question which I have done question number first 2 questions in the objective 2, question number 4th and question number 5th. Question number 4th and question number 5th, which I have done in the objective 2. Keeping this in mind only. Anyone doubt from 56 to 60?
56.
56 not required this week, better. 56 requires nonce equation. 56 not required this week.
Okay.
From anything except 56, 56 to 57 to 60.
No, sir.
57 to 60 better.
So 60th question, only the D option.
1 coulomb. Once I am going for the water, once I am going for the 1 coulomb, you know very well that 96500 coulombs, 96500 coulombs is Avogadro number of the electrons. Is a Avogadro number of the electrons. So 1 coulomb will be how much equal to, based upon that you can go for.
Thank you.
Anything up to 64, 62?
No.
Up to 62. Now coming for electrolytic conductance. In conductance, applications of the Kohlrausch law is there this week. Already number of questions we have done from the Kohlrausch law last week, means your some questions last week and some questions on the Monday and the Tuesday. But still, if you are having any doubt in the Kohlrausch law, you can ask. Question number 76 Kohlrausch law, 77 Kohlrausch law, 78 Kohlrausch law. So now I will simply go for the page number. Page number 202, 203. Any question, doubt based upon Kohlrausch law? Page number 202 and page number 203. Any doubt on Kohlrausch law?
No,
Say yes or no. If yes, ask. If no, no. What is this?
no, sir.
No, sir.
Any doubt up to question number 90? Any doubt up to question number 90 on the Kohlrausch law? Question number 90 is the example of Kohlrausch law. Question 90 is the example of Kohlrausch law. Any doubt in question number 90?
No, sir.
Now objective 1 completed. Still any question left to in objective 1, definitely ask. Any question left over in objective 1, ask. You know very well in life, I won't take that turn. I have never taken, I won't take in the future also. And same thing I'll take from you also. Never in the life you should move back. Never means never. Any question left over from your side in objective 1?
No,
Any
sir.
question? Sure. Then if it is not there, now I am moving ahead. I am moving ahead and now coming for objective 2, because you have given me green signal that it is not there. Now, coming for the Faraday's laws, coming from the Faraday's laws, from question number 1 to question number 5.
No, sir.
Question number 1 to question number 5.
No, sir.
Question number 6 to question number 10.
Sir, 9th one.
I'll go for the 9th one. The number of electrons involved in the electrode deposition of 63.5 grams of the copper. 63.5 grams of the copper. Don't forget this one. 32 grams of the copper is nothing but equivalent weight. And equivalent weight is equal to Avogadro number of electrons. Equivalent weight is equal to Avogadro number of the electrons that is there. If equivalent weight is equal to Avogadro number, and so can I say 64, which is nothing but roughly 63.5. So 64 grams of the copper. Can I say it becomes double?
Yes, yes, sir.
Yes, sir.
And therefore answer is third option.
Yes, okay.
And third option. Actually, gram atomic mass of the copper is 63.5. Everywhere for the convenience, I will take 64. 64 means cutting or solving will be very easy. In the examination, lesser and lesser time you will take the solving. More and more scope you will get to read the question properly, revise the question properly. That is important, it is there. Anything up to question number 10th? Any doubt?
No, sir.
Question number 11th to question number 15th.
Sir, 14th.
I'll go for question 14th. 1 coulomb of charge passed through a solution of AgNO3 and copper sulfate. The ratio of the amount of the silver and the copper deposited on the platinum electrode and for the electrolysis. You know very well. You know very well. What you know? 96500 coulomb, also called as a 1 Faraday. It is nothing but equivalent weight of the substance deposited. Nothing but equivalent weight of the substance deposited. So 96500 coulombs is nothing but 108 grams of silver. Therefore, 1 coulomb is equal to how much? So X is equal to 108 divided by 96500. Now I'll go for the another one. Another one given is a what? Copper is given. So we know very well 96500 is equal to 63.5 grams, sorry. 31.75 grams of the copper. Therefore, 1 coulomb is equal to how much? Now simply take ratio.
Sir,
Question is
directly
asked
we can
ratio.
use second law also.
Pardon?
Second law we can apply, sir, directly.
Your wish you can apply second law. What is there? Same quantity is there. Yes, same quantity is there. Straight away you can apply the second law. Yes, correct. Just correct better.
Yes, sir.
Anything up to question 15th? Question 15th.
No, sir.
16th to 20th. 16th to 20th.
Sir, 16.
I'll go for 16th. How many coulombs of electricity is required for the oxidation of the 1 mole of the water to dioxygen? 1 mole of the water to that of dioxygen. It is yesterday's class question. In addition to that, this example I have taken in the theory part because I know very well it's a very common example. In a net cell electrolysis of the water, 4 moles of electrons are required. 4 moles of electron. This is nothing but 36 grams or 2 moles it is there. So from this, it's very clear that 2 moles of the water requires 4 Faraday, means 4 moles of electron. Is nothing but 4 Faraday. Therefore, 1 mole of the water requires 2 moles of electron or 2 Faraday. This is basic thing. This is the basic you have to know inside your mind. Now coming for the question. Question is asked, how many coulombs of electricity is required? Now we know very well that 1 mole of electron is equal to 96500 coulombs. So therefore double 2 moles of electrons, how much equal to double? So 96500 into 2. Two Faraday, 2 into 96500. Anything up to question 20? 21 to 25. (21 to 25).
So 23.
I'll go for 23. Same amount of electricity is passed through a solution of AgNO3 and HCl. If this much amount of silver is obtained in the first case, the volume of the water, hydrogen. Same quantity of the current. Just now some boy or the girl has mentioned that, sir, we can apply second law also now. Yes, I told yes, second law can apply because in that question, in both cases, 1 coulomb and the 1 coulomb is there. If the same quantity of the current they have given, means you can apply Faraday's law straight away. So I'll go for the weight of the silver divided by weight of the hydrogen, equivalent weight of the silver, and here equivalent weight of the hydrogen. Weight of silver they have given 1.08. Weight of hydrogen we are not knowing. Equivalent weight of silver is 108 and this is 1. So can I say weight of the hydrogen is 0.01 gram? Can I say? Once we got information weight of the hydrogen 0.01 gram, same type of the question I have done in the objective 1. Once we got the weight, it's very easy to calculate the volume at the what STP. Why? At STP, we know very well 2 grams of the hydrogen is equal to all the 4 options they have given in terms of the what cc. So 2 grams is equal to 2400 cc cubic centimeter. Therefore, 0.01 gram or 1 into 10 to the power of minus 2 grams is how much equal to? So by this, 2 zeros are getting cancelled. This by 2, can I say 112?
Yes, sir.
Yes, sir.
Answer will be 112. Anything up to question 25? (26 to 30). 26 to 30. 26 to 30.
Sir, in 26th one, will it be 1:2:3 or 1.5?
Let us go for Y2. Let us go for Y2 take hit and trial. Y2 take hit and trial. They have given alumina. They have given alumina. They have given alumina. Y2 take hit and trial. Then they have given copper sulfate. Then they have given copper sulfate. And then they have given sodium chloride. All are there in the fused form. All are there in the fused form. And definitely the question is asked the amount of the aluminium, copper, and the sodium. So in this case, aluminium is there in the form of Al+3. In this case, copper is there in the form of Cu+2. In this case, sodium is there in the form of the what Na+. It is well known. Question is saying that 3 Faradays of electricity is passed. We know very well that this charge is a +3, and therefore 3 Faradays are required to deposit 1 mole. 3 Faradays are required to deposit 1 mole. Here charge is a 2, so therefore 2 Faradays are required to deposit 1 mole. Here charge is 1, therefore 1 Faraday is required to deposit what? 1 mole it is there. Question is asked, now in all the 3 we are passing 3 Faraday. Here requirement is 3, we are passing 3 Faraday, and that is the reason why amount deposited will be 1 mole only. Here requirement is a 2 Faraday, but we are passing more than required. How much we are passing? 1.5 times more we are passing, and therefore requirement is a 2 Faraday is a 2 mole. 2 Faraday is a 1 mole. So 3 Faraday is nothing but 1.5. Here requirement is the 1 Faraday, but we are passing 3 times more than required, and that is the reason why in this case we are having the 3 mole it is there. So if anywhere such option is there, 1, 1.5 and the 3, that is the answer.
Second option.
Yes. This is the requirement. This we are passing. As per requirement, 1.5 times more than required, 3 times more than required. Any doubt up to question 30?
Question 29, sir.
Question number 29. 29th question done yesterday. What is the approximate quantity of the current in coulombs required to deposit all the silver from 500 into 1 mAgNO3? So first we should be in the position to know what is the formula. As they have asked coulombs, so straight away I can go for W is equal to Q, or here I can go for the purely your wish it is there. On the place of the C into D, I am going for the Q. Now in the question, what is question? Quantity of current. So quantity of current means it is a Q. Valency of silver is 1. Atomic mass of silver is 108. AgNO3 won't be deposited. Ag plus will become Ag, and that will be deposited. AgNO3 will not deposit. It won't deposit. So now I'll go for the stoichiometry or solutions and colligative properties. Molarity into gram atomic mass into volume in liter is nothing but weight of the substance. This is the formula I have taught you in stoichiometry and solutions and colligative property, molecular mass. AgNO3, if it would have been deposited, I would have been taken gram molecular mass of AgNO3. But out of the AgNO3, only Ag plus is deposited. Ag plus is nothing but it is an ion in the form of an atom, and therefore rather than writing molecular mass, I'll go for the atomic mass. In the question they have given molarity is 1 on the place of the weight. Molarity is 1, gram atomic mass is 108, volume is 500 divided by 1000. By 1000, it is liter. This is ml. Anything from 30 to 35?
31.
No, coming for 31. Yes, 31 is the question which I have told you people yesterday to remind me. First, I will do in the class, but none of you have reminded me. Chalo, problem is not there.
Sir, I got the answer, sir.
Thank God, at least now you people reminded me. Now coming for the question of nitrobenzene. Yesterday time constraint was there. That is the reason why I have not gone for. Now coming for this. So you have to know this one better. If this you are not knowing, you can't solve. This is nitrobenzene. Nitrobenzene on reaction with the 3 moles of the hydrogen, it gives rise to aniline. This undergoes reduction, aniline, and this is our aniline. 2 oxygens are there. That is the reason why 2 moles of water. Therefore, 2 2s are 4 hydrogen plus 6 hydrogen. Therefore, here I have gone for 6. This is very correct reaction. But by this reaction, we won't get any idea. By this reaction, we won't get any idea regarding number of electrons required. So same reaction I will write in terms of charges. Once I will write in terms of the charge, then we will get information regarding the number of electrons. Then we will get information regarding the number of electrons are there. And now this I am writing as NO2. Other than writing this, I will write 6 hydrogen, 6 hydrogen. Same thing. Writing in the charge form is giving advantage that we got information regarding number of moles of electron. Number of moles of electron is nothing but water. Number of the water, Faraday's it is there. Now coming for the molecular mass. Coming for the molecular mass, can I say molecular mass is 123 grams?
Yes, sir.
Yes, sir.
So 123 grams is equal to 6 Faraday. 6 moles of electron, it is 6 Faraday. Therefore, 1.23 grams means 100 times less, 100 times less, 100 times less, 0.06 Faraday. So same reaction, deliberately, consciously, I have transformed into ionic form. Up to 35, question number
Sir, 35.
35. 4 moles of electrons were transferred from anode to cathode in an experiment on electrolysis of water that we know very well. Total volume of the 2 gases, so 3 moles it is there, therefore 67.2 liters. Therefore, 67.2 liters at the STP. They have given the story, that story we know very well. That story we know very well. They have given the story and unnecessarily they have made the question big. They have given this story. For the 2 moles of the water, 4 moles of the electron is required. This we know very well. 2 moles of the hydrogen gas and 1 mole of the oxygen gas. Question is asked, volume of the both gases. So 2 plus 1 is equal to 3 moles it is there. At STP, 1 mole of a gas is equal to 22.4 liter. Therefore, 3 moles of a gas is equal to X. On cross multiplying, it is 67.2 liters. 67.2 liters. So 1 mole of a gas, 22.4. 3 moles of a gas, 67.2. Question number 38 is still pending. Yesterday, I have given the framework. I was expecting last answer from you, but you people have not responded. God knows, you people have applied glue, Fevicol, glue, what you have done now. Anything up to question number 38?
Sir, 36.
Now coming for 36. 36 straight away charge is there. So 1 Faraday of electricity is passed separately through the 1 liter of the 1 molar aqueous solution of Ag plus SnCl4 and copper sulfate. The number of the Ag, Sn and the copper deposited. Till now, this is 5th question of same type. This is fifth question of same type since yesterday. So let us go for the order. What order they have given? Order they have given is we want from Ag plus we are getting. Now we are having from the reaction Sn plus 4.
Copper sulfate.
So from this, it's very clear that for 1 mole of this, requirement is 1 Faraday. 1 Faraday will go for the 1 mole. 4 Faraday will go for the 1 mole. 2 Faraday will go for the 1 mole. So for 1 mole, we want this many Faradays. Now let us go for the given. Clearly in the question, they have given as a 1 Faraday. The requirement is 1 Faraday. We are passing 1 Faraday, and that is the reason why 1 mole. Requirement is a 4 Faraday. We are passing only 1 Faraday. So can I say 1 by 4 mole?
Yes.
Requirement is a 2 Faraday, but passing only 1 Faraday. So can I say it is half mole? So check any such option is there?
First option.
Any option is there? First option.
First.
1, 0.25, 0.5. So if you will write this type of the framing, never means never mistake you will do and never doubt you will get. Getting doubt in front of me, problem is not there, you're welcome. Getting doubt in the front of the teacher is always welcome condition. I'm talking regarding yourself. In front of me, you get number of doubts. It's a good condition. Anything up to question 38? Question 38 is a pending. Question 38 is a pending. Again, I will write.
5 millimoles.
Pardon, better?
It's 5 millimoles.
Yes, it's 5 millimoles. Very good. Very good. So this is the way I have taught you yesterday regarding call-based electrolysis, and have taught you call-based electrolysis can be understood maybe by free radical mechanism or maybe by the ionic mechanism. Actually, it is this condition. This R and the R is a combining and gives rise to R and the R. This is a combining and gives rise to 2 moles of the carbon dioxide and 2 electrons, minus and minus 2 electrons. This is a combining and gives rise to 2 moles of sodium hydroxide. This is a combining. This is a combining and giving hydrogen. This is our call-based condition, it is there. Clearly in the question, they have given that this one. Q is equal to C into T. Clearly in the question, they have given current is 1 and time is how much? 965. So from this, it's very clear that 965 coulombs is there. We know what we know. We know very well that 96500 coulombs is equal to 1 gram equivalent or equivalent weight. Therefore, 965 coulombs is equal to 0.01 gram equivalent or 0.01 equivalent weight we got. Once we got this one, now we are having this formula. What formula? Normality is equal to molarity into n factor. Gram equivalence corresponds to normality. Molarity corresponds to number of the mole. So gram equivalent is 0.01. Molarity or number of moles is a question mark. N factor is a 2. N factor is a 2. So I'll go for the number of moles. This I am thinking molarity as a number of moles is equal to 0.01 by 2 by 2. It is nothing but 5 into 10 to the power of minus 3 moles or 5 millimoles. This is nothing but milli or 5 millimoles. So yesterday up to this we have done, I was just expecting this from you people. Answer is 5 millimoles. Anyone doubt here?
No.
So evening my study hour official class is there 5 to 6. Definitely I'll come at 5 to 6. Now I won't invite. Official class is there bhaiya 5 to 6. Those who are coming, they'll clarify doubts. Those who are not coming, not bothered. I am not at all bothered. But yesterday, I was not at all happy. And I'm telling you, I am human being. Number of times from first year, I'm telling you, I'm not a god. I'm not a god. Maybe other lecturers might be behaving like a god. They are god. I'm human being. And human being feels. Human beings emotes. Human beings is having emotions. I felt very bad yesterday. And this I'm expressing openly in front of you. Expressing openly in front of you. And definitely, if this will be repeated, I'll keep in my mind for a longer time. I'll keep in my mind for a longer time. For a longer time. Correct? And one saying it is there. Sanjay Singh se dosti bhi achhi nahi hai. Sanjay Singh se dushmani bhi achhi nahi hai. Both are not good. Both are not good. Both are not good. Very, very careful. Very means very, very careful. I'll keep in mind. I'm telling you, I'm a human being. As you are small kids, first time, second time, third time, fourth time, I'll go on pardoning you because you're a small kid. But that does not mean it is not there in my mind. And once I'll get saturated, like Shishupala and Lord Krishna, Sudarshan Chakra, I have to go on. Sudarshan Chakra, I have to throw. And Sudarshan Chakra will behead, that's all. So see that, don't test my patience. Don't test my patience. Yesterday you have tested my patience. Okay? So see that, today evening, those who are having a doubt, all are welcome. Still you are having the problems, or I'm having connectivity issues there, this and that. I'm helpless, better. I'm helpless. Let us meet at 5 o'clock for rest of doubt clarification.
Sir, at 5 we're having zoology class, sir. Zoology class.
My class is 5 to 6. Then tell me 4 to 5 you're free?
Yes, sir. Okay, sir.
Then all of you 4 to 5. Then all of you 4 to 5. Next time ask your zoology teacher that they should not jump in my class. Okay?
Sir, actually, we thought
Yes, sir.
your class is from 4 to 5. Sir. We only told ma'am.
Okay, once you told madam, today you again tell madam, next time you don't jump, it's our mistake, it is there. Sanjay Singh don't like the people who jumps, correct? So today, because your mistake it is there, you are a small kid and I'm your teacher. As I told you, Shishupala and Lord Krishna, number of times I'll go on. Ab paap ka ghada dheere dheere bhar raha hai. Now slowly, you people are saturating me. Don't saturate me up to that point that I should act in different way. Okay, so we all are meeting at what time? 4 o'clock. Okay, so again confusion should not be there, because when I have started the class, at that time strength was 142, now 118. So God knows that buggers will join when they'll join at 5 o'clock or what. So class is there at 4 o'clock. Okay, so therefore you only put a message in the group. Padmaja madam class is there 5 to 6. Sanjay Singh sir chemistry study hour 4 to 5. You only put in the group. Okay?
Yes, sir.
Okay, sir.
Yes,
Chalo beta. See you. Thank you.
Thank you, sir.
Bye, sir.
Thank you, beta. Thank you. Bye. Thank you.
Thank you, sir.
Bye, beta. Bye. Thank you.